Hello friends, I welcome you in lecture number 5 on logic. In this lecture we will see some examples on construction of truth tables. We have already discussed about truth tables in previous lectures, and in this lecture we will see how we can construct truth tables for some compound statements. And before watching this lecture you must be now familiar with these connectives, which are negation, conjunction, disjunction, or inclusive or exclusive or, as well as implications, conditional statements, one-sided as well as two-sided, that is biconditional. We can use for biconditional, we can use these different notations also. Here we can write P if and only if Q in this way, or some authors are using this type of arrows on both sides, and some authors are using this double implication also. So all these are nothing but biconditional statements, and these are the different notations. So with this in mind, we try to construct the truth table for the statement formula P or negation of Q. We know that if we are not given a particular statement and if we are using only variables, then that formula is called statement formula. Now whenever we are constructing the truth table, first we have to determine the number of propositions in the given statement formula. So we can see here we have two propositions P and Q, and we have to construct the truth table for P or negation of Q. So P is already there, Q is there, so we will first require the negation of Q, because we want disjunction of P and negation of Q. This operator is called disjunction or inclusive or. So we first have to determine negation of Q, and after that we can determine this disjunction of P and negation of Q. Now here I have two propositions P and Q, so I will have four possible rows or four different possibilities for truth values of P and Q. As we have discussed in earlier lectures, one possibility is P and Q both are true, then P is true and Q is false. Another possibility is P is false and Q is true, and last is P and Q both are false. And we will make this convention that we will always write in this way. Otherwise we can write this last row as first, second or third row. There is no compulsion in writing in this way, but we will follow this convention that first we assume that P is true, then there are two possibilities for Q, true and false. Then we assume that P is false and there are two possibilities again for Q. Now here we will write truth values for negation of Q. So negation of Q has truth value which is opposite to the truth value of Q. So here Q is true, therefore here I must write false. Here Q is false, therefore negation of Q is true. Here Q is true, therefore negation of Q is false. And here I have F, so I will write T here. After that we have to write disjunction of P and negation of Q. So for disjunction or inclusive or, we know that if we have disjunction of two statements, then that disjunction is true if at least one of the two statements is true. Here I want to write down disjunction of P and negation of Q. So this has truth value true denoted by capital T if either P is true or negation of Q is true or both are true. So here for first possibility we have true and false, and because P is true or at least one is true, this has truth value T. Here both are true, therefore we require at least one truth value as T for this to be true. Here we can see both are false, therefore this becomes false, and here one is false, another is true, therefore this has truth value T. So it is very easy to write down the truth table for given compound statement or for given statement formula. All we have to remember the definition of connectives, and we can write this systematically as a table. Here I have just written without table, but we should write properly by using some table like this so that it will look nice. So in this way it is very easy to prepare the truth table. Here I have prepared truth table for disjunction of statement P and negation of Q. So in this way we have to write properly truth table for given statement formula. We consider another example for the construction of truth table. Here we can see we have truth table for conjunction operator, and we have to take conjunction of P and negation of P. So for that first I am writing proposition P, then I will require negation of P, and after that I will combine these two by using this conjunction logical operator or AND operator. Now I have only one proposition denoted by capital P, so I have only two possibilities, true and false, and this is negation of P. So when P is true, negation of P is false. When P is false, negation of P is true. And here I am using AND operator. So we recall the definition of AND operator. Suppose I have A and B. I have conjunction of two statements A and B. Then we know that this is going to be true if and only if both are true, otherwise it is false. So for the first possibility, here we have negation of P as false, therefore this becomes false. This is true if both are true. Here also one is false, therefore this is false. So this is the truth table for P and negation of P. So we should write systematically. We can draw rows and columns like this. Then we construct the truth table for P or Q or negation of P. So here we have two statements P and Q. So let me write P and Q first. P and Q are there, and we require negation of P also. So here I am writing negation of P, and I require disjunction of P and Q, and after that I require disjunction of P or Q and negation of P. So because I have two propositions or statements, I have four possible combinations for the truth values of P and Q. For P we write T, T, F, F. Then for Q we write T, F, T, F. Negation of P is having truth value which is opposite to statement P. So here I have T, T. Therefore negation of P has truth values F, F. And when P is false, negation of P is true. And then here I have to take disjunction of P and Q, and whenever we have P or Q, then it is true if at least one is true. So we can see here both are true, therefore this is true. Here P is true, therefore P or Q is true. Here Q is true, therefore this is true, and here both are false, therefore this has truth value false. Now in the next step I have to take disjunction of these two, P or Q, and negation of P. So again we apply the same definition of OR. This is true if either this is true or this is true or both are true. So if at least one truth value is T, then this has truth value T. Here we have T, 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 therefore this is going to be truth value T. Here also we have one statement having truth value T, therefore this is T. So you can see it is very easy to write down the truth tables. Next truth table is for conjunction of P implies Q and Q implies P. Before that we recall the definition of this conditional statement. This means if P is true, then Q, and we know that this is false if P is true and Q is false, and otherwise it is true. The implication P implies Q is false in the case that P is true and Q is false. In all other cases it has truth value T. So that we have to remember while constructing the truth table. So here also I have P and Q. So first I have to write down different possible truth values for P and Q. Then here I will write down P implies Q. I require Q implies P also, and after that I will take conjunction of P implies Q and Q implies P. So first we write down different possible values for P and Q, T, T, F, F. Here I will write T, F, T, F. Now by the definition this is true, this is false if P is true and Q is false. So this is the only one possibility in which this conditional statement is false. It is false if P is true and Q is false. In all other situations it has truth value T. Now for Q implies P, by the definition this is false if Q is true and P is false. So here we can see Q is true and P is also true, so it is not false. Here Q is false, so we don't worry about P, it is always true. Here Q is true and P is false, therefore this becomes false. Okay, again I recall Q to P. Q implies P is false if Q is true and P is false. So in this situation Q is true and P is false, and we have Q implies P, therefore Q to P becomes false, and in all other cases it has truth value T. Now we can take conjunction of these two. Conjunction means AND operator, and we know that conjunction is true if both these statements have truth value T. Here both are true, therefore this is true. here this is false, therefore this is false. Here we have f, therefore f, and here both are true, therefore we have truth value t. And then we can write down, or we can construct truth table by drawing rows and columns so that it will look nice. So in this way we can easily write down the truth table. For implications also, here we have taken conjunction of two implications, p to q and q to p. In the next example, we construct the truth table for this biconditional statement. This notation, if I am writing this notation, then this means it is biconditional statement that we have already discussed, A if and only if B. And we know that biconditional statement is true if both the statements have identical truth values. That is, if A and B are true, then biconditional is true. If A and B are false, then also biconditional statement is true. So remember, biconditional statement is having truth value t in the case that both the statements have identical truth values, either both are true or both are false. So here we will require, first we will require statement P, then statement Q, then we will require P and Q. Okay, this we will require. After that, negation of P and Q, then we require negations of P and Q. So here I write negation P, negation Q, and negation P or negation Q. Instead of speaking negation P, we can speak this as not P, not Q, not P or not Q, in this way also. Now we start by writing different possibilities for P and Q. For P we write true, true, false, false. For Q we write true, false, true, false. And for P and Q, we know that P and Q is true if both are true, otherwise it is false. So here we have f, f, therefore f. This is negation of P and Q. That is, if I have T here, I will write f. Here I have f, 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 therefore I am writing T, T, T. Now negation of P. P is T, T, f, f, therefore here we have f, f, T, T. Negation of Q means if Q is true, negation of Q is false. Here I have T, F, so I will write F, T. Same thing for remaining two combinations, F, T, F, T. Now I have to write down disjunction of not P and not Q. For disjunction to be true, we require at least one proposition true. Our disjunction is false if both are false. Here both are false, so this is F. Here this is true, here this is true, here both are true. So in all other cases, disjunction is true. And finally we require this statement here. That is, we have to take these two, negation P and Q, and negation P or not Q, and we have this type of situation here, A if and only if B, where A is this part. Suppose I denote this by capital A and this by capital B, then I want to write down truth values for this biconditional statement A if and only if B, and these are our A and B. This is our A, this is our B, and we know that this biconditional statement is true if both A and B have identical or same truth values. So for the columns of A and B, we will search the possibilities for identical truth values. So we can see here these two are having identical truth values, therefore this is true. Here also we have same truth values, therefore biconditional is true. Here also we have same truth values, therefore biconditional is true. Here also we have same truth values, therefore biconditional is true. So this last column is the truth table which indicates the truth values for this biconditional statement. So in this lecture we have seen that how we can easily construct the truth tables for any statement formula. All we have to remember is the definitions of these logical operators which we have discussed in previous lectures. So I stop here. Thanks for watching.